Okay. Yo, what's up? So, I know I haven't uploaded. Let me check. Last time I uploaded was. Yeah, 9 days. That's pretty rough. I think my last video I was talking about what I wanted to do for my next video. And I wanted to work on making an ESP, right? So I finished the ESP. It just took a little bit longer than I initially thought because I had to learn a lot of stuff. Or, like, it was all basically stuff that I knew, but a little bit more in depth and a little bit more complicated. And some stuff I had no idea about, like vectors and matrices and all that dog shit, linear algebra and shit. So I had to do some learning about that to understand it. I also wanted to make sure I understood everything and like go through and label all of everything before I talked about it. Um, should I do? Oh, should I go fully in depth on? I'm trying to think if I want to make like a full tutorial going over it, but like think if I had to make a full tutorial going over it, we'd have to go over like the hooking part, right? Then we'll have to go over all the drawing functions. We'll have to go over the OpenGL, documentation, how it all works. Like what is the pushing the attributes on the stack does. Push and pop the server attribute stack. Well, this doesn't pop. It just pushes it onto the attribute stack. Um, yeah. Pushes the current matrix stack down by one. Yeah. Yeah. I don't know. Should I go? Should I go through this? I mean, did you? I even like go through it one by one, or can like just looking at it will you understand? I don't know. Basically, what our code is doing is like in our DLL main, right? So I think my last video was coding video was on aimbot, right? Check this out. So it was making an aimbot. Yeah. So we just had. Okay. Well, this is my main like thing I've been working on, my project, I guess. Uh, so this is how I have my DLL main set up, my main function. Which if one is equal to ul underscore reason underscore call, this basically means if DLL process attach. So if we're attaching, we want to disable the library thread calls. Then we want to make two threads, which is my console, my inbound hook, and then close the threads, so we don't have to fuck around with them anymore once we're done with them. And then yeah, so this is my aimbot hook. This runs my reset pointers function, which it basically says do while if any of these are null or not supposed to be, it'll just loop through all of them, make sure they're uh, attributed their right values or whatever, right? And so if they're not, then it'll keep looping. Uh, okay. Yeah, and then we obviously have our aimbot. I fixed my aimbot. The aimbot had the distance closest player wasn't working. I fixed that. I don't even know what I changed from the last time because it's been a while. But yeah, I think our azimuth under Z was not in the set to pitch. It was our absolute pause Z was set to pitch. Also, I changed my naming convention from camel case to, or not camel case, from snake case to camel case, just because a lot of the YouTubers I watch that do coding use camel case. So I just figured to hop on the train. What else is different? Yeah, all that looks the same. Oh, I separated my aimbot and nearest player function. I just separated them into different functions. So we can just call this and then it'll call the nearest player and then it'll run through here if we press the get async key. So there's a little bit of a separation there. Oh yeah, so let's talk about the WGL swap buffers. So uh, the way you make ESP with an OpenGL is by hooking WGL swap buffers, which is the rendering for the graphics within the game. So let me just pull this up so I can show you what I'm talking about real quick. Um, pull this up here. So if I attach AC underscore client and go to my symbols and we go to OpenGL32.dll. All right, let's go back. So instead of OpenGL.32 or 32.dll, we have our export modules. So these are our export modules here, and WGL swap buffers is the export module we want to look at, right? So we go in here, and basically we're going to be hooking at the, let's go to our, we can go to our hook structure real quick. So inside of our hook structure, we have our export name, which is WGL swap buffers. So it's going to be hooking at the first address within the WGL swap buffers, right? And then our module name, which is going to be our DLL name. So the module name that we're going to be getting the process ID of. And because, yeah, we're going to need to get the module name and then the export name to be defined swap buffers, right? And then we have our destination byte pointer. So our destination will be, we can go see what it's set to. I don't know exactly what it's set to. I can't remember. But it's set to, oh, yeah, our destination is just set to our hook swap buffers. And then we have our gateway, which we can, it's right here, but good definition. Our gateway is just our, it's just a type def of bool standard call pointer to WGL swap buffers, and it has a handle to the device context. So we can go and look at that right here inside of our hook.cpp. So these, if you've watched Guided Hacking's video on this, which actually I should probably go look at that, because they made a really good video on this. Like that's how I learned how to hook OpenGL swap buffers without having to use dTOR or anything. Guided Hacking, hooking OpenGL. Yeah, these guys actually fuck hard. So these guys are the ones I learned from for drawing and hooking OpenGL swap buffers. Is this is for CS2? What do they even do here?
So if this pointer is just pointing to junk memory, then these,
I don't know. I don't know what that video is, but C++ and mid function hooking. Anyways, yeah. So if you want to learn how to make the trampoline hook, I'd probably watch these guys. They do like a in-depth tutorial going over it and how it works. I'm not gonna do that because, for one, they'll probably explain it better than I will, and yeah, that's basically all it is. He'll explain it better than I can. So, but for like a miniature explanation, basically we do our dTOR. So this is where it's gonna start our trampoline hook right here. We're gonna start right here. We're gonna check to see if the length of our bytes is less than 5. If it is, return 0. So we're gonna return if our length of bytes less than 5. We're gonna create our gateway, which is gonna be a byte pointer. We have to typecast virtual allocate to byte pointer also because it won't go with our gateway. Yeah, so 0, if you pass 0 into virtual allocate, it'll choose a random address in memory that's available. And the length will be the length of bytes that we want to fucking allocate our fuck around shit to. Mem commit and mem reserve. Can't remember exactly what this thing does, but it's just, I don't know, I can't remember exactly what does this do. Let's try ChatGPT real quick, see what this thing does. Mem commit, memory reserve. In Windows memory management, mem commit and memory reserve are flags as virtual memory allocations. Like virtual allocated specified memory should be allocated. Mem commit, this flag commits a block memory, which means physical storage RAM or page file is associated with the specified region. The memory is not available for use, but the content memory is not initialized. This flag reserves a range of the process virtual address space without committing any physical memory. This memory cannot be accessed until it is committed later on. This flag combination both reserves and commits at memory at the same time. Reserves a virtual address space and commits physical storage. Okay, yeah, so that just makes space and stuff for us to fuck around. And then page execute, read and write. This just means that we have the permissions to execute on, or to read and write to the fucking executable memory that's running. Because Windows doesn't normally allow you to, but virtual allocate allows us to, right? Then we're gonna write the stolen bytes to the array. So I have these little comments to explain it. Mem copy is gonna take our destination, which is our gateway, and then the size, which is our length, so how many bytes we're going to be doing, our source, so the source of whatever we're going to be fucking copying, and then the source size, which is going to be the length again, obviously. We're going to take the same length, the source size, right? Get the gateway to the destination address. So yeah, this is just getting the jump to our address, which is going to be the source minus our gateway minus 5. The minus 5 is for the jump opcode. 0xe9 is a jump opcode in x86 assembly, and it takes 5 bytes. So gotta use minus 5 to make sure it has enough memory for it. Add the jump opcode at the end. Yes, so we're gonna dereference our gateway plus a length, And then we're going to set it equal to 0xe9. Write the address of the gateway to the jump. So dereference the unit pointer gateway plus length plus 1. It's equal to the gateway relative address. Okay, cool. And then we're going to go into the detour. And we're going to pass the source, destination, and len, or length. And that's when we'll go through here. It will just make sure that len is less than or greater than 5. And then here we go. We're going to do the exact same thing. We're going to store the protection, the current protection that it's in. We're going to store it into old protection, store it here. And then we're going to calculate the new address, create another jump code. Basically the same thing we just did. And then we're going to restore the protection afterwards. So we're going to restore the protection, old protection. And then we're going to return true. And then we'll return the gateway. And then, yeah. The rest of the stuff, this just enables the hook. So for like it's disable and enable a hook for we can do inside of our loop. So when we turn it off, we can. That's what our toggle is right here. So look in DLL main, we can now, once we have this struct made, we can then just call dot enable and enable it, and dot disable to disable it. So once this is done running, so until we type quit into the console, then it'll disable it, then it'll close free the console, free library exit thread, and this will also free library exit thread, and that'll allow us to clean up all of our stuff that we have running. Anyway, so once it calls the hook to WGL swap buffers, we go into draw. And in draw, it'll start off like right here. It'll get the device context. Then it'll come into here. And it'll see if it's built. The first go around, it's not going to be built. So it's going to say, it's false. So it's going to go into the build font height. So B built is going to be set to false. So we're going to go into build, and we're going to build font height. Go into here, then we're going to get the handle to the current device context. The base is just going to be the monospaced font does not be the width of every character within the string. This is just setting the font, okay? And then you have the H font, which bunch of dog shit. You can look at that for yourself. It's probably the longest function call I've ever seen in my entire life, so pretty cool. We're using the console as font, so you just copy paste all that if you want to, or just copy through it. The old font, we're going to be selecting our new font and inputting that for our font. So pretty cool. And then we're using the WGL use font bitmaps. So we're gonna be using the handle device context, and then whatever the fuck the rest of this shit is. 32 to 96 is our ASCII fucking letters, I'm pretty sure. Or is it ANSI? I can't remember what the fuck exactly it is. It doesn't really matter. But just know you want it to be set up like this, or else you won't be able to print out the right characters. Or you might be printing out a bunch of random symbols and shit if you don't do it like that. And then, yeah. And then once we continue through here, we're going to set it to true. And so next time around when it comes through here, because we're going to be looping through this draw function over and over again. Every tick of the game, every frame of the game, it's going to loop this entire loop and draw everything to the screen, right? So yeah, then it won't have to do this anymore. And then we can set up ortho, which is going to be disabling our depth rendering and setting our viewpoints and matrices. So kind of like I was going over earlier. You can read through all this. But basically the gist of it is that we're going to be getting our X and Y points on our screen. And we're going to be disable depth testing so that we can draw our fucking boxes in the game. And so that our boxes that we draw are going to be layered on top of everything within the game, so that we can see it through walls, right? Because if depth testing isn't disabled, then we'll be swallowing a load basically. And then what else? So once we go through that, I'm gonna set up the ortho. Okay, we're gonna go through here. Okay, these other ones are only gonna be used down here. Yeah. So once we go through here, we're obviously gonna go through our entity loop. So we're gonna get our enemy offset, which is going to be our index times 4 for every 4 bytes with an entity list. All right, and then dref its entity list. It's a dword pointer to enemy offset. It's an entity pointer to the enemy. We've already gone over this in an aimbot video. We go through that, do our calculations. I don't know if I went over this. I basically made my own math functions for the calculations. So just the origin calculations. We're just gonna take our flow x, whatever x like floats we pass it, and subtract them, and then return the value. So it's going to calculate the origin for y, z, and x values. Then our azimuth, x, y. we're gonna be using the a tan2f function, which pretty sure a tan2f. Maybe this. What does this do? Returns the float value of. Okay, whatever it does to the azimuth, it does it. You can look it up online. I can't remember. So yeah, it's gonna do that to our z and y values to get our pitch. Yeah, we did that for our x and y values for our yaw. We're gonna add the 90 offset to our yaw because or else I think true north in the game is 90 degrees, so we have to add 90. Then we're gonna set our local yaw, local player, right? Get our yaw diff, which is our yaw minus the enemy's yaw. And the yaw difference, this is like basically a normalized angle function. We're just gonna normalize the angles to make sure that they're not over the degrees it's supposed to be, so neck isn't snapping back and forth, right? This right here is our function for calculating where they are going to be on the screen. So instead of using a world to screen function, which you should probably use if you want to, I just didn't use it because I don't fully understand it yet, so I'm not going to implement it. But I will be implementing it soon, whenever I get around to it. I've been working on stuff. So we're gonna take our int x. Let me turn this on real quick. So yeah, this is gonna be okay. It's a bit too loud. So the int x and int y. This is the calculations I did. The way I found these values out is. Did I make a video on this already? No, I didn't. Okay, well, basically the way you find out the values for this is what this value in particular right here. This is just half of our screen. But should we go into our game? We go to settings, go to video settings, screen width 1028, screen height 800. So I'm using 514 and 400 respectively. And then we're going to be adding our yaw diff plus pitch diff multiplied by their offsets, which are these values right here are okay. So if I'm looking at the enemy, did I have it fucking?
I didn't get that. Could you try again?
They're trying to talk to me. I can't remember where. Okay, here it is. It's actually right here. That's fucking funny. Okay, we're lucky us. So, okay. So basically, I'm taking. So when you're in the game, right? Instead the enemy is right here, we're gonna be calculating our yaw. So whatever our yaw value is, while looking forward to see where the enemy's at. You know, if the enemy's at like, he would be. I don't even know. Let's just say he's at like negative 90 yaw. Okay, so this is the far left of our screen. Then we would put. So for the left of our screen, we would have the fucking f value be negative 90, right? Because it's far left. Here, wait. Oh, no, it's right here. So this value would be negative 90. Okay. And then we would then do the calculation to get our f value, which our f value would be, so this our yaw diff, and then our f value would be this right here. And then we're going to add them all up so we get the middle, the left, and the right. And then we're going to get the median of those. So 0, negative 28, negative 25, 3. Then we'll get the median, so the average f value, whatever that is, right? And we'll basically do that for the y and the x. So you can go through that, fuck around with that if you want to, or you can just copy my exact one I have right here. This I just got from trial and error. Then we're going to do, so if the x value is off of our screen, so if it's greater than 1028 or less than 0, y is less than 0 or greater than 800, then it's off the screen, so we're going to continue. Then the way I do my calculations for my boxes to make sure that they're the correct size it's supposed to be, or within the relative dimensions, because I'm not attaching it to like the feet position and the eye position within the game. I'm just scaling them appropriately from distance wise using a fucking function. So we're gonna use temp distance, and we're gonna use this the Euclidean distance function, which is gonna return the square root f, which is to return the square root and float of x times x plus y times y. For x or absolute positive and absolute y, so calculate distance to adjust inside the box. Then we're gonna make the two float values, float width and float height. we take our width and set it equal to, this is a formula I came up with for calculating width. You know, you can use whatever you want to do. This is the formula I used. Yeah, which is adjusted through trial and error. Basically, it's going to take, so this is our default height would be 200.5 or 200.0 divided by our temp distance minus 5. So we would get whatever value this comes up to be. Let's just say temp distance is like 10. So we'd have fucking 20, and then we'd add 30 for our height value, right? Or width. And then same thing for the height. So also made a health bar. So we made our max health bar is equal to 100. So the max health is 100 again. Then we're going to do some calculations to make sure that the health bar scales. So scale the health bar. Health bar height. We're going to take the max health, so enemy health divided by max health multiplied by height is equal to the health bar height, right? And then this is an offset for the x value. This is just to make the x value stick to the character. So x plus equals 5 times square root f of temp distance. Yeah, and then we're gonna draw. So we're gonna draw the screen. We're gonna draw the outline. So the draw function, super easy. If you just look it up, you can search up how to draw. It's gonna be GL begin, and then we're gonna use line underscore strip for our outlines. So basically, you're gonna define 5 vertices because each vertex you define will link up to the next vertex in the list. So this will link to that. This will link to that, and then back to this. So this is gonna be our x and y value, which would be our the bottom left foot, right? And then we'll once we loop all the way around, so we're gonna be going, I think it's counterclockwise, looping all the way around until we get back to x, y again, right? And then we're gonna end the rendering. Same thing for the filled box, except we don't need to do the last vertex because it fills up the area within those 4 vertices. So yeah, pretty easy. Yeah, and the calculations differ this. So this is gonna be our x value, our y value. We're passing in float x, float y, and then our width, which would be the calculations right here. Then our height value, the outline fucking float line value is gonna be 2.0f. I did RGB red. Go to the name says RGB right here. You can look in here. Whatever you want to do, red, green, gray, light. You can add your own colors. It's pretty easy to find the values online. But I'm just gonna do red and green for my my colors because they're vibrant, right? Then we're gonna do our text. So where we want the text to be printed out, which we want to be printed out right above the box. So center height or center text x width string length times height, then font height divided by 2.0f, which font height is defined right here. It's gonna be initialized at 15, so it's font width initialized at 9. Then we're gonna be printing it at the y, so it's y minus font height, right? We're gonna print it in green, right? We're gonna be printing out enemy name, writes name in green, text above the box, true that. And then for this, it's gonna be our health bar right here, so it's gonna be drawing an outline, 9.5 degrees or 9.5x to the left of our original box. And yeah, we're gonna be drawing the outline in red, and then we're gonna be drawing a filled box in green that is scaled to the HP bar. So pretty cool. And then we're gonna restore the GL, which is just gonna go through, pop the matrix, and pop the attributes, and restore them back to their original. And then pass it back to. So once we run through there, we go back to DLL main. Then we're going to. It's gonna run through here. Then it's gonna return the swap buffers. So I'll show you how it works in game now. Am I already injected? No, I'm not. I don't have a console open. So we're in game. We can just inject real quick. I'm gonna use cheat engine. You can use whatever you want to. Process manager or process hacker. Your own. You can make a DLL to inject it. I'm just too lazy. So yeah, look, there we have our character right there. And the health, dude, I like how the health bar actually scales with it though. That's why I think it's so sexy. Oh, that's a little strange. Yeah, so I don't even know why this is right here. But same thing for the aimbot. It's like the Z value calculations are a little bit off. no idea why. So you found out. If you find out why, let me know. But yeah, so there's the aimbot and ESP, and it works pretty good. It renders multiple players too, so we can go here. So we got all these players. So we got one right there, one right there. And yeah, it's down to 1 HP right now. Yeah, the closer you get, the larger it grows too. And we try to make it scale to the size of the character. So like you see how that's scaled over there. If we go over look at him. Oh, attached to the closest person to me. But yeah, it's a pretty gangster. Oh. Yeah, I have no idea what's up with my Z calculations. That's it. Why does it? Anyways, so that's basically the ESP. Pretty fucking cool shit. If you want an in-depth video on, I mean, do I really want to go through doing this from nothing? I don't even know. It'd probably take like 20 million years. But yeah, I think next goal is I want to hook the relative mouse mode with an SDL2, which basically hooks our mouse to the center of our screen. See our mouse? We can't see our mouse if I press the second zero mouse. So yeah, I think that's the next goal is to hook this function, which should be pretty fucking easy. And then we're gonna render a GUI in OpenGL. So right, I have OpenGL hooked. We can draw boxes and make little buttons and shit. And yeah, just to make toggles for like aimbot and ESP, so we can toggle it on. So we would just make like a global variable, kind of like this right here, this atomic bowl, and just add it like right here and say put this in within a while loop, and say while ESP is set to true, then run this, and while not, skip it or continue. Yeah, not bad. But aimbot's looking a lot better though, as long as they're not like up in the sky. See, like that works right there. No, it doesn't. Yeah. Anyways, pretty fucking cool. 28 minutes. Okay. I guess I'll just call it there.